Okay, hi everyone, and welcome to your first little bit of remote learning for maths. Now, I did kind of feel like I took you through in quite a lot of detail last week everything that was happening, but I'll just quickly talk you through it again. So you should have found this via the outline that I'm kind of in the process of organising at the moment. So you can see mine is pretty bare looking, but yours should be full by this stage. And this is the first video and the only video we're going to get you to watch today. We've actually finished everything that we have to do for the term. So I thought we'd just do a bit of extension. I still want you to do it and have a real go at understanding it, but it's not actually stuff that you going to be able to have to do for your test or exam later on in the year. Okay, there's also a bit of optional work here, and I'm going to make you a video tutorial for that as well. So if you want to give it a go, if you're feeling a bit bored or whatever, then feel free. But this compulsory stuff in here, that you definitely have to do and have to watch. All right, this might be a little bit of a longer video today, just because there's a bit of explaining, but hopefully the others will be quite short from then on. Okay, I'm looking forward to seeing you for our Teams meeting on Friday, and we will start. Okay, so Pythagoras is really useful not only for looking at things in 2D, but we can also use it to find things in 3D. So what I mean by that is, if we have this nice cube here, we can use it to find any diagonal across the cube. So going 3D from like the back corner down to the front corner. So I'll draw in a line and I'll show you that. So from this side to this side there, we can find the length of that big inside diagonal. Likewise, we could find the one that goes from A to F, or we could find from B to E, or we could find from D to G, okay, any of those. Right. Now, it's pretty easy to actually do that. All we need to do is do Pythagoras twice, once using the bottom face here. So if I draw another line in here, so once we need to use Pythagoras to find the hypotenuse of this triangle here. So if I just draw this one that goes from A to D, and then A to C, and then across. So if I draw that one there, it would look like this. Okay, you would have A at that corner there, that's your right angle, D at the top, and then C at the front. Okay, and we want to find what is that length there. And then you would use that, I'm just going to use another different colour, we'll go with purple, that one with this height, that top side there, to find that big long one. So then we would have a second triangle, okay, which goes from H at the top, D at the corner, and C there, and we would use that to find that H to C, that big long side, that's that red one that you have there. Okay, I'll just do it in purple so it's the same colour. Okay, so that one there. All right, so I'm just going to go back to GeoGebra where I made this up originally, and we'll start getting some lengths, and then we'll do some calculations for that. Okay, so here's, oh, that's my emails. We don't want that. Here we go, 3D calculator. Okay, so here it is here. So on here, if I go into GeoGebra, I can measure some of these sides. Now I know how long they are because I made this up before, but if I go through here, I can measure some distance or lengths. So I want to know how tall is my cube, and it's got a height of 4, if you can see that little 4 there. It's got a bottom length of 4 as well. And it has a back length of 4. Okay, so its dimensions are 4, and then from there we can go through and do some working out. Just give me a second. All right, back on the Word document. Hang on. All right, so now we found that this side has a length of 4, the height is 4, the length is 4, the width is 4. Okay, so from here we know that that A to D side there, remembering that's that one along the bottom, that one is 4. A to C, that's that one down the bottom, that is 4 as well. And then we can find that length there of the hypotenuse. So if we go into the calculator, we're finding the hypotenuse. Remember, we're adding them together. We have 4 squared plus 4 squared. Okay, gives us 32. Square root of 32 is we'll say 5.7. Okay, we'll do the one decimal place. So that's 5.7 there. Oh, 5.7. And that means that, again, that's that D to C side. So now if we're looking at the big purple triangle, that D to C one, that's 5.7 there. Okay. Now we know the height of the cube is 4 as well. So now that's 4. Okay, so from here we have 5.7 squared plus 4 squared equals 48.49, and the square root of 48.49, okay, is equal to 6.96, so we'll say 7. Okay, so that means that that length there, h to c, is 7. And I'm just going to write a bit of this working out anything else. We have 4 squared plus 4 squared equals c squared equals 32, c equals the square root of 32, so therefore c equals 5.7. Then we had 5.7 squared plus 4 squared equals c squared. Therefore c squared was equal to 48.49. C equals the square root of 48.49. So therefore c equals 7. Okay, so therefore our diagonal, big diagonal length, h to c, is equal to 7. Okay, all right, I'm going to upload some questions that I want you to do with this. It'll pretty much be the same ones. They might not always be cubes. There might be some rectangular prisms, but you're essentially using the same process. Okay, have a go at those. Any problems, let me know. If you'd like another example, let me know. But you guys are super quick and clever, so I think you'll be fine. Okay, all right, see you later. Bye.